In this video, I'm going to prove to you beyond all reasonable doubt that this stuff here is absolutely not household dust that gets trapped in the wheels, and I'm going to explore what it actually is, and why it is, and I'm also going to take a look at these. Let's go. Nearly all printers these days have these wheels on them somewhere, and all ender clones pretty much do. Of course, there's other ways to propel your printer's parts along each axis, but these are popular because they're cheap, reliable, and cheap. For those of you who don't realise that they're not licorice, they are in fact made of a thermoplastic called polyoxymethylene, which is also called Delrin by those who use brand names all the time. Because it's a thermoplastic, interestingly, it can also be used for 3D printing, although it rarely is, probably because it's toxic when heated, and apparently it's hard to get to stick properly to the bed. It is used in a lot of everyday places that you wouldn't realise though, like apparently it's the plastic that's used in your standard issue clothes zipper. Anyway, the first premise is that these wheels are somehow not the cause of the dust, which I feel like I shouldn't really have to waste my time proving, because obviously it's not dust. How would dust get under the bed onto these wheels? But let's have a look at this stuff under the microscope. I collected dust off the gantry, where it's most likely to at least contain some environmental dust if the assertion is correct. And here's the result. It kind of looks like snot after a day trip to London or any other big city, I suppose. But hey, we have no measure here of what normal dust looks like. So I also collected some of the dust off the parts of the printer that are above the gantry, and here's a sample of that. As you can see, it bears very little resemblance to the stuff we got off the gantry. So there we go, within what, less than 2 minutes, I think I'm not timing it, I've already proven that this isn't dust. We can pack up and go home. Video over, we're all done. But okay, let's carry on. What is it if it isn't dust? Obviously it's from the wheels. Yes, but no, but also yes, but maybe no. I also swabbed the area on the filament reel holder, which just happens to be directly above the gantry. And when you look at that under the microscope, what do you know? It looks the same. How could this have got from the wheels? It's not. This is just what plastic looks like, I suppose, plastic dust. So we can't really say, can we, with a clear conscience, that this is only dust from the wheels. Obviously under the bed is another matter. This is easily solved though with the second part of the experiment anyway, so we don't need to go and sample under the bed. The take home here so far is that this dust is probably a combination of unknown proportions of shaved filament reel plastic and POM wheel plastic. Enough of that though, let's pull this to bits and put some new wheels on. These are brand new, apparently official Creality wheels, and I have to say that if your wheels aren't worn, which they probably aren't, as you hopefully understand by the end of the video, then don't bother changing them. They are an absolute pain to change. It should be a 5-minute job, but I think it takes about half an hour just to get everything apart. You've got to remove the hot end pretty much to get them off. Yeah, it's just, no, don't do it. Don't do it unless you literally have flat spots on your wheels and you need to. I've also removed the filament holder and the filament, so it proves that any dust can't be from that from now on. So, new wheels on, it is now testing time. I have a program that cycles the x-axis back and forth. It's the same tool I used for the last video, apart from the one before last, where I was shaking the wheels off. Go watch it if you haven't, it's really cool. But just running that program slower, so you're just going back and forth for 4 hours without shaking anything. It only took a few minutes before I started seeing what I suspected, and before you jump in to tell me that the wheels were too tight and that's what's causing this, no, they're not too tight, we will get to that. Within a very short time, they started to show this dust, and a lot of it. At the end of the first 4 hours, you can see just how much of this stuff there is, and if we take a sample and look under the microscope, yep, it's exactly the same stuff as before, there are no surprises here. So next, a simple task of cleaning this all up and running the cycle for another 4 hours. At the end of the second run, largely the same again, but I think there was less of the stuff, but rinse and repeat, and each time there was less and less of this dust until about the 5th run, which is around 20 hours in. I noticed that there wasn't really much dust being produced at all. So, why? Well, if I bring out the fancy macro lens and show you this cross-section of an unused wheel against the profile, you can see what you probably don't expect. We are conventionally told that the angles don't match, but actually the profile matches better than we're expected to believe if we read the internet. Both of these are actually a really good fit in terms of the angle they are cut at, but what you can see, as you get really close, is that the aluminium profile isn't actually that well made. The angle is correct, but look at it. So what I believe is going on here, it doesn't take a genius to work it out, is that the two surfaces are wearing to match each other, or rather the wheel is wearing in to match the profile, because the wheel is by far the softer of the two. And this explains why the effect is huge at first and slows over a very short time. So by 20 hours it's kind of complete. The wheel profile matches the metal profile. Let's have a look at the wheel after 20 hours or so under the microscope to see what it looks like. You can see that the bottom wheel especially has a distinct line. As I move the light, you can see the ridge has a definite shadow. The upper wheels have a more smooth wear profile that kind of matches the distance, the actual size of the groove that they're riding in. The takeaway from this part, I guess, is that new wheels will wear to match the profile, and how much that entails possibly depends on the quality of the profile itself. I've noticed that Enders are particularly prone to this, whereas my artillery printer has hardly shown any POM scratchings at all. So it does imply that the profile is more accurate on that printer, but testing that is outside the scope of this video. Either way, seeing a ridge on your POM wheel or seeing wear marks on your POM wheel is not a sign that they need to be changed, unless you like changing them weekly just for fun. So final part of this video, I took the POM wheels off and I replaced them with the polycarbonate wheels. I'm sure, like me, you're wondering whether these are better or worse than POM wheels. Being polycarbonate, they're probably a lot more brittle. They're probably a bit more brittle. Apparently they're really not brittle. What I found from running the same set of tests was largely the same pattern, although the dust looked totally different. It looked like chalk marks on the bar, which is weird, but again it gradually decreased over the course of a number of hours. Are these wheels better? No, I don't get that impression. Are they worse? No, I don't get that impression either. I didn't see, hear or smell any difference with them. They don't feel any different on the printer. The only two things I think these wheels have that POM ones don't is perhaps a longer running life and a hatred of certain chemicals. The former doesn't really matter as much as the POM ones because the POM ones last for ages anyway unless you're running a print farm. But the latter point is very important, I guess, especially if you use acetone to clean your bed. Then probably avoid polycarbonate, they don't like each other. I've also heard people saying that the polycarbonate wheels can crack after exposure to IPA, but I don't use it, and I don't trust anything I see on the internet, because apparently this shouldn't happen. Another thought, really finally, is that if the polycarbonate wheels are tougher, then they might actually wear the paint off the bar, so I don't know whether that happens or not. If that has happened to you, then please comment below. Well, I think that just about wraps up this episode. Have you changed your wheels ever? If so, why? Comment below. See the description as always for Discord, Patreon and any corrections as usual. Oh, and speaking of Patreon, from this point now, I'm going to trial a change that lets Patreon members see videos first without ads. I'm going to experiment with it. I'll start with just like a day in front so that it doesn't delay the video by much, and we'll see how it goes. It's not an official perk. If it doesn't work out, I'll just stop doing it. If you're interested, you'll find the Patreon link below. Otherwise, I've got another video coming out in a few days. I will see you then.